Now, I would like to invite Dr. Amjed Al Thuhli, consultant for future for technology and development, to introduce his topic on advanced AI.
Assalamu alaikum. Thank you, COMEX group, for inviting us to learn from each other. And I would like to start my presentation in advanced AI. My presentation will be mostly technical, so it is good also to learn a business side and also technical side. So since most of the CEOs and VIB have left, the event, so we can just start by this cartoon. You can see here the CEO is asking this guy, are we using the artificial intelligence in our company? And the employee said, no, actually we are using statistics with a bit of machine learning. So there are some confusion between these terminologies, machine learning, artificial intelligence. And in this presentation, I'll try my best to clarify the difference, and also I'll try to talk about the advance of algorithms used in artificial intelligence. So basically, once we define the advanced artificial intelligence, that means we are using more than one algorithm in order to solve a complex problem or to take a decision. We have a lot of types of artificial intelligence. We have machine learning, we have natural language processing, NLP. We have also expert system, vision, speech, planning, and robotics. So these type of algorithms are available, and you can download it and you can use it in your programming, and you can use it also in your systems. You can mix between each others in order you have a complex problem, or if you are researchers like a PhD researchers. So let's start with the machine learning. In machine learning, actually we have three types. We have supervised learning, we have also unsupervised learning, and we have deep learning. So in order to define the three main bars and three main differences between these type of machine learning and advanced machine learning, let's take some examples. So the main difference, first of all, between the first two, supervised and unsupervised learning in these algorithms, the supervised learning, as you can see, it classified the data, or I can say the observation. Since I'm feeding the system with the data, that means I'm feeding the system with observation. So it classified it to, right or wrong, or red or green. So it classified them into, for example, diseases, not diseases, yes or no. However, the unsupervised algorithm, it's group the observation, group the data. To be more clear, suppose we have these pictures. In the first example, we input some apples, and we annotate the system, annotate the algorithm, and in order to cheat the system, this is apple. So it will give us, is it apple or not? But in the second type of unsupervised learning, we have some, photos and some pictures, and the system by itself, it will group the similar photos. So this is the main difference between these type of algorithms. So supervised and unsupervised algorithm, that means we have different cases. In each case, we have to identify what type of algorithm we use, either whether it is supervised or unsupervised. So let's now talk about the deep learning and the advanced deep learning. Basically, the deep learning, it depends on the neural network, which is more than 3 layers in the programming language. It means that I'm feeding the system with inputs, and it multiplies these inputs with some sort of mathematical equations in order to bring the bias in the transform function. And after that, it will also activate the function to get the final results. So almost it's trying to simulate the human brains in order to give us the correct answer. So this is the very advanced deep learning in the machine learning. So basically this deep learning and advanced deep learning, it's working without human interventions in order to improve the automation and perform analytics and any type of physical tasks. So the main difference between the machine learning and the deep learning or advanced deep learning, the machine learning, it interacts and also extract data with the help of human, but the deep learning, it's doing it automatically without human help. So we have to distinguish again when to use the machine learning and when to use the deep learning. So let's have some use cases from the current situation. We have right now with the World Cup in Qatar, they are using the semi-automated offside technology. It's helping the VAR technology, which is most of us don't like it because it's not making, the football game excited because the VAR will cancel some goals as we have seen in many matches. So the technology itself, it's helping the team who are working in the VAR control room in order to repeat and repeat again and again. They have more than 12 cameras in the stadium. These cameras are watching every single player with 29 points in their bodies. Imagine that your bodies is moving with 29 points and it's sending signals to the control room every second 50 times. So I'm moving right now, they are collecting 29 points from my body and sending it to the control room in order to manipulate it using also the deep learning. However, the decision will be helped by human. So the referee inside the control room will help also the main referee in the field to take the final decisions. As well, today we have a smart ball. It has a small chip. It sends more than 500 signals per second to the control room to know the exact position of the ball inside the field. So this is the advance of artificial intelligence in the football currently introduced by FIFA in Qatar. Another good example of the deep learning where European Space Agency and NASA using it in their rovers when they send it to the space, whether to the moon or whether to the Mars. Imagine the signals coming from the Mars to the Earth, it takes around more than 10 minutes. That means if I need to give instruction to this rover to move a little bit or just to rotate the tire, that means I will need more than 20 minutes just to give the instruction. That's why they put some sensors, they put some also laser beams, they put some cameras depending on the deep learning and advanced artificial intelligence in order to take the proper decision. This rover is moving using its decision without human interventions. That means it can detect whether to move right or left or move, for example, with a speed of 1 kilometer per second or less. It depends on the object in front of this rover. It depends also on the roof or the grooves inside, for example, the environment. So that's why they are using it in the space. Another good example from space as well, IBM with Airbus, they came with a project with the German Space Agency with a small robots. It's called Simon. This robot, it's fully automated with artificial intelligence. It helps astronauts in the International Space Station to take the decision in case of emergency, because the life without gravity is very difficult. Astronauts in the International Space Stations, they have very restricted timetable for their life within 24 hours. They have to do exercise, they have to sleep well, they have to do some experiment in the lab. With this robot, it's called Simon, it's fully integrated with deep learning applications. They can talk, they can, with these robots, and also they can take the decisions and it help them to perform some tasks. This is another example done by some academic institute, also I think in the United States. They have used deep learning classifications. Here they have used 4 deep learning classifications in order to collect data from X-ray and CT scan. And they did a pre-processing in order to identify 4 types of diseases. They have successfully identified COVID-19, and they distinguish COVID-19 from pneumonia and from as well lung cancer using 4 types of classification. That's why when I say in the beginning of my slides, you can combine many algorithms inside one complex cases or inside one complex problem in order to identify or take a decision. So that's why here they have used more than one method in order to identify type of diseases. Another type of advanced AI is called edge machine learning. That's mean we are using the machine learning on the edge devices like cameras, like sensors, where I think Mr. Hassan, he just mentioned the example of ACs inside these holes, and it can be taken inside, instead of sending the signals and instead of sending the data to the data centers, it can be automatically sending to the local devices, and it take the proper decisions in order to increase or decrease also the temperature. So with edge machine learning, we can have proper security and enhanced security. We can also predict the maintenance, and also we can detect any fault in our protection line, like this use cases done by Amazon Web Services. Once they install some devices in cameras and some IoT devices, one of the hangars, in order to decide which part goes to, which engineer and to which, for example, systems to be maintained. So in these cases and in these use cases, scientists, they have successfully reduced the cost and reduced the time in order to maintain the aircraft. The same things can be happened in any type of garage. Another part of advanced AI is called natural language processing, LNP, where we have different types of natural language processing. It's basically a computer science, artificial intelligence, and linguistics. Especially people who are working in linguistics, whether in Arabic, English, or any type of linguistics, how we can understand from this language, how we can manipulate this language and transform this language into a service. So that's mean once we speak to any devices, how we can export our languages, our voices, and produce a service. So we have many types of techniques. That's mean many types of algorithm. It can be used in a natural language processing, like for example, stop modeling, sentiment analysis, machine translation, and keyword extraction. So let's take an example. Suppose I'm talking to a machine. Suppose I'm talking to, for example, Alexa or to the Siri, and I would like to know whether my command is positive or negative. So just I have mentioned the mission was great. The mission was great, so the machine will translate, this sentence into some classification. So the sentiment analysis in natural, AI, advanced AI, it will classify the sentence into parts. First of all, let's understand what we mean by sentiment analysis. Actually, basically, sentiment analysis, it consists of three parts. The first part, it's called the training sets. It's like a dictionary. I feed the system, whether automatically or basically manually. I can add some local accents in order to feed the system, whether if it is a good word or satisfied word, neutral word, or not satisfied word. That's bad words. The second part is called the classifier, where I can put my sentence in this classifier, and the system itself, it will use the advanced AI to classify my sentence, to classify, for example, my any type of paragraphs to decide whether I'm happy or not. So in the classifier itself, so let's see what will happen in the classifier itself in details. So the classifier, first of all, it will tokenize the sentence. The mission was great. That's mean it will cut the sentence into words. The mission was great. The second part, it will remove the special characters. That's mean if I have stop word and special characters, discrimination, any type of special character, it will be removed. The third part is to remove the stop words. For example, the, was, is, any type of the word will be removed. The fourth step is to classify. Here, that's mean I have to put the positive plus and negative, minus and neutral 0. Then I have to calculate the weight of each word. Once I calculate the weight of each word, I can conclude whether my sentence was positive or negative. So basically, this is the idea behind the natural language processing in the advanced AI. Another interesting example, recently OpenAI, they have announced a chat GPT, which is like informal way of interacting with a chatbot, and it can answer any type of questions, and it can debug any type of code. Just put your code there and it will debug it by itself, and you can challenge it. It will give you the correct answer. You can correct it if it is wrong, and also it can reject any bad words. So it's using the reinforcement learning from human feedback algorithm. I have tested actually by myself, and maybe Mr. Omar can correct me here with this one, and maybe we can correct also the OpenAI team. I have asked actually this chatbot about any idea about the COMEX 2023. This is the answer highlighted by the green. The chatbot immediately, it answered me, COMEX 2023 is the 23rd edition of the commercial exhibition conference, and the second and the third line. The second question was where. Imagine where. I haven't asked, so I put delay actually between the first question and the second question, almost 2 minutes. And then I asked where. So it took actually the first question and it matched it with the second question, and it gave me, it will be happening. COMEX 2023 will be held at the Oman Convention and Exhibition Center in Muscat, Oman. The third question was, who is the group CEO? Group CEO of who? Of COMEX. The answer was the group CEO of COMEX, Mr. Ali Hard. Is it correct, Mr. Omar? So we have to correct, I think. So this is the wrong answer. I meant to copy it here because we need to challenge, because this is a new natural language processing from OpenAI, and it gives me this answer. The next question was, give me the contact, please. It gave me that you can contact COMEX at blah, 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 and email info. Is it correct, the COMEX team? Is it correct, the telephone and email? I haven't verified it. I'm verifying immediately with the COMEX team. Is it correct? It's almost correct. What about the focus area? It gives me the focus area. And imagine once I ask this question to the chat, GPT, I put some minutes between each questions in order to, verify and test the accuracy of the answer. But almost I can say right now it's more than 90% accurate. The second question is, I use my natural language in order to ask, give me the best code for Twitter sentiment analysis to be used in the Python. And after a few seconds, it gave me the following code can be used with the Twitter sentiment analysis, and this is the code. So you don't need to be a programmer in the future. You just ask the chatbot, and you can just copy the code and use it in your programming. Another type of advanced image recognition, that's mean we have advanced AI today with object detection. We have also advanced AI with OCR, where the airport, staff scan our ID cards and also our passport. Face and body recognition. Some cameras here, they can identify the speakers. Some cameras, for example, even they can identify you from the back, not just from the front. If you have not Omani, Dishdasha, of course, because Oman Dishdasha is very wide. Also, we have virtual speech, image capturing, content filtering, and moderation, where you can filter the internet content, whether at home or in the service provider. So just to conclude my presentation right now, the future of advanced AI will interact with human. It's called human-centered AI. So it's like, AI taking and learning from our inputs, and it will help the human to be more advanced in doing their, capabilities, in doing their activities, like patients, like people who are in critical areas, firemen, astronauts, or people who are climbing, for example, mountains. So basically, scientists right now, they are working with some academic institute in order to reform, the business plan and the business model of the AI. Instead of AI replacing the human, AI will help the human to be more smart and help the human to perform more tasks. At the end, advanced AI will move the centralized application, where today we have it in our organization and companies, to be a decentralized applications in order these systems to talk to each others and to be in the future a decentralized application to perform more tasks in a smarter way, faster way, and precise way with low cost and with more economic impact. Thank you very much.
Thank you, Dr. Amjed, and thank you all speakers.